The Flying Laser Shark's ME1720 design project. Who are we? Brendan Wright is a freshman in geological engineering. His favorite part of the project was the building. Lane Schnell is a freshman in aerospace engineering. His favorite part of the project was the building. Bailey Adams is a freshman in environmental engineering. Her favorite part of the project was writing the memos. Nick Covert is a freshman in computer engineering. His favorite part of the project was the grunt work. Our project. The Flying Laser Sharks project had humble beginnings. But we improved. This is the proof of concept 2, this is the alpha prototype, and this is the final prototype. The Flying Laser Sharks knew they needed a safe, reliable, affordable, and convenient machine that could push a garage door opener after 30 seconds using 4 unique energy transformations. The final prototype was safe, it was affordable, it was convenient, and it was kind of reliable. We got it to work at least more than once. The 4 unique energy transformations we used were electrical, rotational, kinetic, and gravitational. Electrical. Our final prototype included copper wires that produce electricity when connected via a timer. Rotational. We included a pulley system that rotated to pull down a hammer to hit the garage door opener. Kinetic. To start the function of the machine, a ball was dropped by hand down a tube. Gravitational. Gravity was used when the ball fell into the cup, which triggered the motor's electricity. How the whole thing worked. First, a ball was dropped by hand down a tube. At the same time, the 30-second timer was released. Next, the gravity of the ball fell into the cup, which started the motor. The timer then counted down 30 seconds until the motor pulled down the hammer, which pushed the button. But it sure didn't start out that way. Each prototype test had different outcomes that we learned from. Alpha prototype. A motor was added to the pulley system to create movement. We replaced cardboard and duct tape with PVC piping and plywood. We made our alpha prototype to the correct scaling. But did it work? Some things worked and some things didn't. The ball fell down the tube and triggered the motor, but it fell too fast. The motor's function was effective, but it wasn't strong enough. Testing results. The timing was 7 seconds, and we had 4 energy transformations. It was safe, but it was too long. It needed to be cut down. Lessons learned. We need to find a way to get the timing longer. We also need a stronger motor. Beta prototype. A coiling tube was added around the main tube. The coil tube added 10 seconds. The structure was reinforced with plywood and nails. But did it work? In some ways yes, and in some ways no. The coiling tube increased time by 10 seconds, but it still only took 17 seconds. The structure was more sturdy, but the dowel rod still didn't exert enough force to push the button. Testing results. The timing was 17 seconds, there were 4 types of energy transformations, it was safe, and the constraints were met. Lessons learned. We still need to increase our time. We also need a stronger button pusher. Final prototype. The machine was painted and decorated with the team name and logo. A hammer replaced the dowel rod for a more forceful push. A 30-second timer with steel wool and copper wire attached increased time and power. But did it work this time? Yes, sometimes. The timing was correct, but only when we got the wires to connect. The hammer had enough force to push the button, but it wasn't consistently triggered by the motor. Testing results. Unfortunately, the wires didn't connect for final testing. We had 4 energy transformations. It was safe, but we didn't meet the constraints. The hammer made it too long. Lessons learned. We need to be more consistent in order to produce successful results. Summary of testing results. Here's a summary of our testing results. We improved the timing each time, consistently had 4 energy transformations and safety, but we did not meet the constraints consistently. So what if we could start this whole thing over? Brendan Wright says, I would have met more as a team so we could have created a better initial sketch and built the machine less precariously. Wayne Schnell says, I would have designated more time to putting it together and figuring out how to get the wiring better. Bailey Adams says, I would have liked to work more as a team and use different materials and made sure it worked before testing. Nick Covert says, I would have tried to be more proactive in general, whether that be helping on the project more or making sure that we worked on it earlier. What we learned throughout the project. It is important to collaborate and work together on design projects. Using time wisely or not can make or break a design project. If a design project is not consistent, its function does not matter. Although our project may have not been a success, we all learned a lot. Thank you for watching the Flying Laser Sharks presentation. And now, a video of our final prototype.